Hello guys, welcome to the chemistry revision. In today's chemistry revision, we will be focusing at nanometers. So today's chemistry revision is focused on nanometers. Okay, so I just collected questions from different past papers on nanometers and then decided to answer them so that you have an understanding of how questions are brought from nanometers. Okay, but I advise you guys to go through the videos that are on nanometers and also study some of the books that are talking about the preparation of nanometals uses and their characteristics such as physical and chemical characteristics. Okay, because I might not have covered all the nanometals in this revision. Okay, so let's go straight into the revision. Question 2, C2 says the calcium oxide is an important compound that is manufactured from limestone. So calcium oxide is an important compound that is manufactured from limestone. Okay, so A Roman numeral 1 state the method by which calcium oxide is made from limestone. 1 mark. Then Roman numeral 2 write a balanced chemical equation for the formation of calcium oxide from limestone. Include state symbols. Then 2 marks. Then Roman numeral B, what is the common name for calcium oxide? 1 mark. Then we go to C, during production of calcium oxide from limestone, a gas is evolved as a byproduct. Roman numeral 1, describe the test for the describe the chemical test for the gas. Then Roman numeral 2, by what method is the gas collected when prepared in the laboratory? Give a reason for your answer. Then Roman numeral 3, state 2 uses of the gas. So in answering, what we should know when we are talking of calcium oxide, I mean limestone is calcium carbonate. So the method which is used to prepare calcium oxide from limestone is thermodecomposition. Okay, so the answer is thermodecomposition or heating. Okay, then we go back where they said write a balanced chemical equation for the formation of calcium oxide from limestone include state symbols. So the method here we have said it is a thermodecomposition. So thermodecomposition is the process by which a metal or a compound is heated so that it breaks into two or decomposes into two. So you heat a compound like limestone, then limestone breaks into calcium oxide and carbon dioxide. Okay, so now you form calcium oxide. Now here they're saying write a balanced chemical equation for the formation of calcium oxide from limestone include state symbols. So the answer was here. So this is calcium carbonate. It is in solid. When it undergoes a thermal decomposition, which is heating, it forms calcium oxide. Okay, this one here, and then it also forms carbon dioxide. So calcium carbonate is a solid, so the state symbol they wanted, you put S to indicate that this is a solid. Then calcium oxide also is a solid, so you put S to indicate that it is in a solid. Then carbon dioxide is a gas, so you put G at the end to indicate that the state in which carbon dioxide is a gas. Then we go to uh, B says what is the common name for calcium oxide? So the common name for calcium oxide is quick lime. Okay. Then they're saying during production of calcium oxide from limestone, a gas is evolved as a byproduct. Okay, we have seen that gas, which is carbon dioxide here. So it's the one they are talking about. They're saying Roman numeral 1, describe the chemical test for the gas. So how do you test the the presence of carbon dioxide? So carbon dioxide is tested, or the presence of carbon dioxide involves bubbling the gas into um, lime water. And if the gas is carbon dioxide, lime water turns milky. So this is what we said. Pass the gas through lime water, it turns lime water milky or cloudy due to the formation of calcium carbonate. Okay, then Roman numeral 2. By what method is the gas collected when prepared in the laboratory? Give a reason for your answer. So what method is used to prepare carbon dioxide? So carbon dioxide is considered to be a gas which is denser than air, and because of that it is prepared by what we call um, downward displacement of air, okay, or upward displacement, sorry. So answer, the gas is collected by upward displacement, sorry, the gas is collected by upward delivery because carbon dioxide is denser than air. Okay, so we can say upward delivery or displacement of air because carbon dioxide is denser than air. That is that. Give a reason for your answer. We have given the reason 2 marks. State 2 uses of the gas. So since we know we are talking of carbon dioxide, the uses of carbon dioxide are: one, it is used in fire extinguishers. Why? Because it doesn't support burning. Then it is used in making carbonated drinks because it has um, a flavor. It adds flavor um, to the drink. Then we go to B8. It is on urea, which is under nanometal. Urea, which is this, and ammonium nitrate, which is this, are two nitrogenous fertilizers commonly used by farmers. So then they're saying Roman numeral, but they're saying A, calculate the percentage composition of nitrogen in urea. So I didn't answer this one because it is coming from more concept, but still more I have to answer it so that I start covering some of the things in more concept, but I know we already covered more concept. So in calculating, okay, sorry, okay, so in calculating what we call, let me just get something here to use. In calculating what we call percentage composition, um, like we can say percentage, I will just put composition C is equal to um, mass, we can say relative formula mass of element over relative formula mass of the compound, then times 100%. So you get this urea because they're saying calculate the percentage composition of nitrogen in urea, like how much is nitrogen here in urea. So you get your urea, this is okay, sorry, let's do like this, C or open brackets NH2, and then we have 2 outside. So if we want, we can clear out the 2, so we can say this is the same as a CO, then N has a 1 down here which we don't show. 1 times that 2, it will be N2, then H has this 2 down here, 2 times 2, 4. So now we'll add the total relative formula mass of each one of these so that we find the relative formula mass of the compound. This is the compound. So carbon, the relative formula mass on the periodic table is 12. Then oxygen is 16. Then nitrogen is 14. Then hydrogen it is 1. So we total these up here. So we say 12 plus oxygen 16 plus nitrogen 14 times 2 is 2 down here. So that 14 times 2 because there are 2 atoms of nitrogen. So say 14 times 2, then plus, then hydrogen 1 times 4, it will just be 4. So now this will be 28. So let's just add quickly. So I'm going to add, I'll just add it all together like 12 plus 16, okay, plus 14 times 2, okay, then plus 4. I'm getting 60. So it means the relative formula mass of the compound is 60. Now, that of nitrogen, so this is the relative formula mass of the compound. That of nitrogen is found by just nitrogen is N2 in this compound here. So you say 14 times 2, which is 28. So now we will just do what? Substitute. So say, okay, this means 28 over 60 times 100%. And say equals 60. So you divide 28 divided by 60 equals 10 times 100 equals, so 46. So you can just say 46. When you round off 36, you get 1 from this next 6, you add there 7, like that. So that is the answer from more concept. Okay, so let's move to the next question. So the next question, which is B, was like, explain the importance of nitrogenous fertilizers in agriculture. So the importance of nitrogenous fertilizer in agriculture is that they provide nitrogen, which is essential for the synthesis of proteins, promoting healthy plant growth and high crop yields. Yeah, so when you hear that we have nitrogenous fertilizers, these are fertilizers that contain nitrogen. So their importance in agriculture, these nitrogenous or nitrogenous fertilizer, is that they provide nitrogen, which is essential for the synthesis or formation of proteins, because in the formation of protein, nitrogen is very important. So they provide nitrogen, which is essential for the synthesis of proteins, promoting healthy plant growth and high crop yield. Then they're saying describe the effects of using nitrogenous fertilizers on the environment. So the effect is that the effects of nitrogenous fertilizers are eutrophication, soil acidification, and greenhouse gas. So these are uses of nitrogenous fertilizers. They make, if the fertilizers go in water, they cause the process called eutrophication, where the river becomes so fertile that the river water becomes so fertile that there will be a growth of a green substance plant which is called alga. This green plant which is called alga traps actually sunlight from going into the water, which makes it very difficult for other living things to have light. Then also uses oxygen, which makes it also harder for other living things in the water to use that oxygen. So it also causes the soil to be acidic because it produces nitrogen oxide, which is more like acidic. And also greenhouse gas, because these nitrogenous fertilizers also contain like carbon, which is a greenhouse gas. Okay, so a greenhouse gas is a gas which, when released into the atmosphere, traps light energy or traps heat energy from the earth from escaping into the atmosphere and causing the heat to accumulate in the Earth's atmosphere, contributing to what is known as global warming. So, Dean, the same, apart from nitrogen, name an element needed for Roman numeral 1 root development. So, plants have got roots, and roots need to develop or grow. So, apart from nitrogen, we also need phosphorus for root development. Also to seed formation. For seed to form, we also need potassium. So if you are a farmer, you need to ensure that you buy the fertilizer that are usually called NPK. N for nitrogen, then P for phosphorus, then K for potassium, because they will be nitrogen will be able to provide um, N will be providing nitrogen for synthesis of protein. Then P will provide phosphorus for root development. Then what is this? Potassium, which is K, will provide the seed formation. So very important, guys. Then we move on to the other question. This was C2. Okay, so it says nitrogen is used to manufacture ammonia as shown in the diagram. So this question is on the Haber process, which is the process used to produce ammonia. So you will at least revise on it. So nitrogen is used to manufacture ammonia as shown in the diagram. So this diagram, you study it very well, guys. You need to be able to be studying these diagrams very well. Like when you look at this diagram, when you look at this substance nitrogen and substance X, they are meeting here, meaning this and this are reacting to form one substance, which is ammonia. So there is a condition uh, Y degree Celsius and catalyst, and then there's also another condition Z atmospheric. So these are the conditions which are necessary for the formation of ammonia from nitrogen and another element X here. So A says name the process shown above. So this process by which ammonia is formed from nitrogen and the hydrogen is known as the Haber process. So the answer is Haber process. Okay. Then the saying state the substance represented by letter X. So for you to form ammonia, you need two elements, which is nitrogen and another one. So here you can just know ammonia is written as NH3. So another element that is already given there is nitrogen, this one. So the other one missing there, it's definitely hydrogen. So when they say state the substance represented by letter X here, it is hydrogen. So nitrogen, hydrogen will give you ammonia. So the answer here is hydrogen. Okay. Then the same C, write the conditions represented by Y and Z needed for the process. So the process of formation of ammonia from nitrogen and hydrogen requires a temperature of about 450 degrees Celsius. So Z or Y is temperature around 450 degrees Celsius and then Z is pressure around 200 atmospheric or atmospheres atm. Okay, then we get back, we're saying uh, D Roman numeral 1, name the catalyst used. So this catalyst is iron. So the catalyst used is iron. Then we come back the same. Oh, sorry, we are actually here. The same. Roman numeral 2, write the main ore from which the catalyst named in D1 is extracted. So the catalyst is iron, right? So they've mixed now production of ammonia with extraction of metals. So what does this mean? It means that in science, especially physics and chemistry, which are sciences, they like mixing equations from different topics. That's why it is very important that as you go to an exam, you revise almost on each and every topic, and this is why I like revising each and every topic, not only those in the prediction, because I know that some questions might just come from other topics you did not predict. Okay, so when they say um, write the write the main ore from which the catalyst named in D Roman numeral 2 is extracted, it is actually hematite. The word ore, it means a compound from which a metal is extracted. So iron is extracted from an ore or compound known as hematite. So here we said hematite, and this is the chemical formula because hematite is iron 3 oxide. Iron 3 oxide. Okay. Then E, the saying construct a balanced chemical equation for the reaction shown in the diagram, including state symbols. So, okay, they want us to write a balanced chemical equation for the reaction here. We should also include the state symbols. State symbols are symbols which indicate the state in which a substance is, and at your level, the states that substances are, or the states that we know to exist at your level are solid, liquid, and gas. So we should write a balanced chemical equation for the reaction between nitrogen and hydrogen to form ammonia, and we should also include the state symbols. So in doing so, it is just nitrogen plus hydrogen. Okay, so let me just do like this a little bit. I'll get back to I just want to do this so that we begin from 0 so that I help you to balance a little bit because balancing is very important. So you say nitrogen, okay, like this, it is a gas, okay, put state symbol plus hydrogen, it's a gas, so you put G as a state symbol. These two, when they react, they give you ammonia NH3. So ammonia, you must always know in advance the chemical formula for ammonia is NH3, and it is also a gas. Now, how do you start balancing? You start looking at atoms individually, like this nitrogen here, it has two. It means there are two atoms of nitrogen. When you come on this other side, there's N here and there's a one here which we don't indicate. It means that we have one atom of nitrogen. Now, in nature, there's no way you can have two nitrogen atoms here, then here at the end of the reaction you have one. They'll ask you to say, where have you taken the other one? Because according to the law of conservation of mass or matter, matter cannot be created nor be destroyed. So meaning the number of atoms that we started with should also be the number of atoms we end with. So if nitrogen is 2 here, we should also make it 2. Now some like putting like a 2 here. No, that would be wrong. So you just put a 2 in front. sorry, you put a 2 in front. Let me get my pen. So you put a 2 in front here. So when you make a 2 in front here, it means you have balanced as far as nitrogen is concerned. Nitrogen, there are 2 atoms. Nitrogen also, there are 2 atoms in here. Now you shift from nitrogen, you come to hydrogen. How many atoms of hydrogen are here? Because of these 2, there are 2 atoms of hydrogen. But when you come here, we see 3 atoms of hydrogen. Apart from that, because of a 2 in front here, this 2 does not only affect nitrogen, it also affects hydrogen. So it means that hydrogen atoms are 3 times 2, they are 6. Now, if you have 6 hydrogen atoms here, you come back here, you have 2 hydrogen atoms. What can you do to make them 6? It's like you have 2 hydrogen. There are how many? There are 2 like this. So what can you do to make them 6? You add 4 more. Okay. Now, here there are how many? 2. So they are already 2. So now you start counting how many pairs? 1, 2, 3. So here we had 1 pair which contained 2. So for them to go to 6, we should do 2, 4, 6. How many pairs here? There are 3 pairs. So you need to put a 3 here. So that 3 times 2, 6. 3 times 3 times 2 here, 6. So then you have balanced 3 hydrogen atoms, 3 times 2, 6. Then 2 nitrogen atoms, 2 nitrogen atoms. So this is just to do something on balancing equations, okay? But I'm very sure that other videos that I posted already talked about this, okay? So let's just go back so that we have our original. Oops, we have even lost our original equation due to what we were writing. Okay, it's fine. Then we go back to the question. The other question now says the state 1 use of ammonia. So let's go for 1 use of ammonia, manufacture of fertilizers. Okay, then now let's go to another question. So we are now looking at another question, which is question B6. B6A says the reaction between 4.2 grams lump of magnesium carbonate and 0.1 molarity hydrochloric acid is relatively low. The reaction can be increased by either increasing the temperature or using a catalyst. Okay, we are told that there is a reaction of magnesium carbonate, which is 4.2 grams, and the hydrochloric acid, which is 0.1 molarity. And they're saying this reaction is relatively slow, like it is slow, it's not going faster. Then they're saying the reaction can be increased, meaning it can be made to go faster by either increasing the temperature or using a catalyst. Now they're saying other than increasing temperature and using a catalyst, state any 2 conditions that can be applied to the reactants in order to increase the rate of the chemical reaction. Okay, so they're saying apart from what they've already helped you here with, you state as any other 2 conditions that can be applied. Like you have magnesium, a solid, reacting with hydrochloric acid, which is aqueous. So these 2, when they react, they form magnesium, because magnesium removes the hydrogen here to make magnesium chloride. Then the hydrogen which is displaced comes out as a gas. So you can balance the equation by putting it to there. Now, since the reactants are one is in solution, another one is in solid, you look at where the question is coming from. So this question is coming from a rate of chemical reaction. I don't know why I even picked it, but anyway, rate of chemical reaction. So when we are looking at the rate of chemical reaction, we are studying how fast the reactions go, and there are factors that affect how fast the reactions go. There are factors there. One of them is temperature. Okay. Another one is concentration. Now, concentration affect um, reactants in solution or aqueous form. Then another one is pressure. Okay. Now, pressure affects the reactants in a gaseous form. Then another one is the catalyst. Catalyst affects any type of reactants. Then another one is actually this one, surface area or size of particles. Size of particles. So these are some of the factors which affect the rate of chemical reaction. We say the higher the temperature, the faster the rate of reaction due to increased collision or due to increase the kinetic energy of the particles, which leads to more collisions, leading to increase the reaction. Then concentration leads to increase the rate of reaction due to increase the number of particles reacting. Then pressure also the same. Pressure brings particles reacting together, so it increases the collision, leading to increase the rate of reaction. Then catalyst, a catalyst lowers activation energy, aiding the reaction to go faster. Then size of particles increases the rate of reaction by increasing the surface area that is exposed for chemical reaction. Okay, so now having talked about these things here, okay, having talked about these things here, as in just a reminder, I've done this one just to bring fresh your memories. Now we can understand how the question is moving. When they say that um, when they say that apart from, okay, let me get my mouse. Where has it gone? What have I done now? My highlight has disappeared. Who has made it to disappear? Let me bring it back because it is helping to move where we are going. Okay. So now, what are we saying? So we are saying that they said we they said state any two conditions that can be applied to the reactants in order to increase the rate of the chemical reaction. So the condition number one, increase concentration of reactants, especially increase the concentration of hydrochloric acid, which is in aqueous state. Then another condition is increase the surface area of reactant, especially magnesium, which is in solid, because concentration is for reactant in aqueous, then surface area is for reactant in solid form. So then we go to Roman numeral 2. They're saying explain how a catalyst would increase the rate of a chemical reaction. you explain how a catalyst would increase the rate of a chemical reaction. So in answering, we are saying a catalyst provides an alternative reaction path with a lower activation energy, increasing the rate without being consumed. So yeah, that's how it does. So a catalyst provides an alternative reaction path with lower activation energy. So consider chemical reactions as needing energy. More like when a chemical reaction is taking place, it's more like a vehicle climbing a mountain and going on the other side. Okay, so it will require a lot of energy to climb the mountain, right? Drivers, I think, understand. But yeah, that is what it is. But if you want to make the car not to use a lot of energy to climb to go the other side of the mountain, then you make a road through the mountain. You dig a road through the mountain there so that the vehicle passes through that without using a lot of energy. So that's what a catalyst does. It's like it lowers that mountain which is needed for the reaction to climb. It will lower that so that the reaction do not climb anything. So it will give an alternative reaction path. So reaction will go in a different path. Okay. So like let me just illustrate something like this. It's like this. Um, this is energy that is needed, and this part is what we call reaction progress. So let's say the reactance energy is here. This is the reactant energy. Then the product energy is here. You find that there's what we call energy barrier. There's what we call an activation energy barrier where for reactants to reach the product side, for reactants to reach the product side, there'll be what we call energy barrier here. So there's this activation energy here. So I need to overcome this reactant to go the other side. But what they do, catalysts, when you use them, they provide an alternative, like the reaction will just go there from reactant to product. So I hope you are getting something from what I am trying to explain here. Okay, so now let's move to the next question. Question 8b. Oh, sorry, question B says name says B nitrogen. Uh, okay, nitrogen and hydrogen react under suitable conditions to produce ammonia following the reaction below. So nitrogen and hydrogen forms ammonia. Then Roman numeral 1 give the numerical values of A and B. So A and B. So they've hidden, this is just a balanced reaction. So other people found this question hard, but it wasn't. Like if you rewrite this one, say okay, nitrogen as a gas is reacting with hydrogen as a gas to produce what? Ammonia as a gas. So balancing equation, you start with nitrogen 2, nitrogen 1, you put A2 there. Then you balance, then you come to hydrogen 2, hydrogen 6, you add the 3 here. So then they decided to not put 3 there, they decided to put A there, like the way they did, and here they decided to put B. Then they said what value, what numerical value is A and B representing. So I said A is representing 3 and B is representing 2, just like that. Okay, as simple as that. But you see that when they find such questions in an exam, they say, the exam was hard. No, the exam is never hard. It just requires you to think, to use your brain a little bit to think. That's what these examiners want, not only the examiner. That is what science is all about. Science is about making you think, not keeping your brain lazy. That's not how science is. Then Roman numeral 2, they say, apart from temperature and catalyst, mention one other factor that can increase the rate of the production of ammonia in the equation above. So they're saying apart from temperature, which we know helps to increase the rate of production of ammonia in this reaction, they're saying mention one other factor apart from temperature and catalyst. So another factor is pressure, increasing pressure. Why have we chosen pressure? Pressure affects reactant in gaseous state. So we have reactant N2 nitrogen, it is in gas, and H2 hydrogen is in gas. So increasing pressure will increase the rate of production of ammonia, because there will be more collision between nitrogen nitrogen and hydrogen, leading to the formation of ammonia. Okay, then we move to another question. So this question C1 says the diagram below illustrates the laboratory preparation of ammonia. So they have shown us how ammonia is prepared here. Look at the diagram. We have ammonium chloride and calcium hydroxide there. So ammonium chloride and calcium hydroxide, they are inside here. Then condensed steam. Here there is condensed steam which is formed. They heat them and there will be condensed steam. Then the gas comes out here, passes through substance X, then forms ammonia gas. So this is the whole process which is used, or the laboratory apparatus used to prepare ammonia in a laboratory. Then A, they are saying construct a balanced chemical equation for the reaction being illustrated in the diagram above. So remember, ammonia is formed by reacting a base and an ammonium salt. So calcium hydroxide is a base, then we have an ammonium salt. What are the products? The product are, one, you should have water, then another one should be ammonia, then another one is a salt. So like you have ammonium chloride, which is NH4 plus, then calcium hydroxide, which is a C, open brackets, or H, close brackets too. So you need to know these things. So ammonia. So now, always these guys, when they are reacting, you should know that there will be a salt. So a salt will be formed between a metal and a nanometal. So it will be calcium chloride like this. Plus, then once you know there will be that salt, then go ahead to say there will be just ammonia gas, which is like this. Don't even go back to start looking at how are they going to be. No, go straight. And what? And water. That's how it is. Okay, so that's what we are asking to say. Construct a balanced chemical equation for the reaction being illustrated in the diagram above. That's how it goes. And the same B Roman numeral 1 state B Roman numeral 1 what are you supposed to do? You state the common name of substance X. This substance X here, it is a drying agent which is used to dry, because when ammonia is formed, it goes with some water vapor, condensed steam here to carry, it will be wet going there. So when it comes here, it has to be dried by a substance which uh, absorbs water. So it will be dried, then this one comes out dry. So that substance is the one they are asking for, the drying agent. Like then C, the same. Why is ammonia collected by using the method shown above and not above water? Okay, so we will answer this also. Then D, describe the chemical test for ammonia gas. Then E, state two uses of ammonia. So let's start answering. So the formula, the chemical equation, which they said upper, construct a balanced chemical equation for the reaction using being illustrated in the diagram above. So when they put 2 marks, they will not say include state symbols. When they say include state symbols, they usually put 3 marks. So this is the equation which I already showed you. This is how it is balanced. Then we come to B, Roman numeral 1. State the common name of substance X. So we said answer calcium oxide. So here I think it was going to be calcium oxide or quicklime. Then we say what is the purpose of substance X, like X the same. So we are saying to absorb moisture and dry ammonia gas. Yeah, just as I said, to absorb moisture and dry ammonia gas. Then C, why is ammonia collected by using the method shown above and not above water? This is the answer. Ammonia is less dense than air, so it rises. This is one answer. Also, it is soluble in water and would dissolve in water if collected over water. So the best answer was this, not this. Okay, because they have said not using water. So because of that question which says why is ammonia collected by using the method shown above and not above water? Yeah, so it's saying it is soluble in water and would dissolve if collected over water. Yeah, so if they use water here, ammonia will just go there, dissolve in water and form ammonia hydroxide. You will not have ammonia gas. Why? Because it is soluble. Then D, describe the chemical test for ammonia gas. So in describing, we say ammonia gas turn red litmus paper blue. Ammonia gas turns damp red litmus paper blue. Also produces a white smoke with hydrogen chloride gas. Okay, so the main one is actually the first one. That's the main answer there. Okay, so ammonia gas. Okay, let's do this. Ammonia gas turns damp red litmus paper blue. When a red litmus paper is made to be damp, it means you have made it to be wet. So, I mean, a red litmus paper, you wet it, then you introduce it in a test tube containing ammonia. So that ammonia, that red litmus paper will turn blue, indicating that the gas is ammonia. Then state two uses of ammonia. So we can say manufacture of fertilizers and manufacture of explosives. Then we go to another question, which is C3. The exhaust fumes from an internal combustion engine contain the pollutant gases, carbon monoxide and nitrogen dioxide. Okay, so this question usually like these, we don't teach them these. They are known as cross-cutting issues, more like when we are talking of issues that are affecting the world. Those issues we call them cross-cutting issues, like issues to do with HIV and AIDS. Those are cross-cutting issues because they affect the entire globe or the earth. So even questions like these, they are not there in the syllabus, but you'd find that they bring them because they're cross-cutting issues. So they were, I think, in the old syllabus, which we stopped using in 2013. So they're saying the exhaust fumes from an internal combustion engine contain the pollutant gases carbon monoxide and nitrogen dioxide. And many vehicles have a catalytic converter fitted on their exhaust system. So the engine, when it is burning the fuel, these gases are produced, carbon monoxide and nitrogen dioxide. So these are pollutant, they pollute the environment. Now they're saying because of this, many vehicles have a catalytic converter fitted on their exhaust system. So the exhaust system is that pipe which carries these gases from the engine to throw them outside. Now that pipe on the middle, they have put something like a tank, which is known as a catalytic converter. So, A, they're saying describe the chemical reactions which occur in the catalytic converter to reduce the emissions of carbon monoxide and nitrogen dioxide. So you explain what reactions happen there, which makes these gases to be neutralized so that they don't have that polluting effect they have. Then in Roman numeral 2, write a balanced chemical equation for one of the reactions that occurs in the catalytic converter. Then B, briefly explain the effect of carbon monoxide on human beings. Then C, suggest two other ways of minimizing pollution of the air by these two gases other than using a catalytic converter. So start now answering. Describe the chemical reactions which occur in the catalytic converter to reduce the emission of carbon monoxide and nitrogen dioxide. So in answering, we are saying carbon monoxide is oxidized to carbon dioxide. Nitrogen dioxide is reduced to a nitrogen gas. So these are the two reactions which goes on in the catalytic converter. There is carbon monoxide being oxidized to carbon dioxide, then nitrogen dioxide being reduced to nitrogen gas. Then when we come back to Roman numeral 2 says write a balanced chemical equation for one of the reactions that occurs in the catalytic converter. So we wrote these three of them. Like for the first one, um, which for the first one, let me see the question, maybe one of them is wrong. Write a balanced chemical equation for one of the reactions that occurs in the catalytic converter. Okay, I think this one, the first one, is not viable. Carbon, no, it's viable, yeah. So carbon monoxide, this one reacts with oxygen to form carbon dioxide, which is less harmful. Okay, then or nitrogen dioxide, this one is reduced to nitrogen oxide plus plus what? Plus oxygen. Then this nitrogen oxide reacts with carbon oxide, this one here, carbon monoxide, to form nitrogen and the carbon dioxide. So the car engine produces a lot of carbon dioxide, which is also very dangerous, but it's not as very dangerous as carbon monoxide and the nitrogen dioxide. Okay, so these are some of the reactions going on there. Then we come to be briefly explain the effect of carbon monoxide on human beings. So we are saying answer carbon monoxide binds with hemoglobin in the blood, reducing oxygen transport, causing suffocation and potentially death. Yeah. So this carbon monoxide here has high affinity for hemoglobin, meaning that if the environment produces carbon monoxide and we breathe carbon monoxide will go and bind with the hemoglobin. Hemoglobin is supposed to bind with oxygen, which we use for respiration. Now, between oxygen and carbon monoxide, hemoglobin attracts more carbon monoxide than oxygen. So if you release oxygen and carbon monoxide together, hemoglobin will pick carbon monoxide. And this carbon monoxide is poisonous, it's not helpful. So instead of breathing oxygen, you are breathing this, you will die of suffocation because you will not have oxygen, lack of oxygen. This is what happens when people go inside the house with a brazier with windows closed because the brazier is burning carbon using oxygen. If oxygen is not enough, the, the gas that will be produced from that burning is carbon monoxide. And you, as a person being in that very room where carbon monoxide is being produced, you start breathing carbon monoxide instead of oxygen, and you end up dying. And many people have died, and people have been accused of witchcraft, not knowing that ignorance also is costly. So, yeah, so the effect explain briefly explain the effect of carbon monoxide on human beings. Is what we are saying. Carbon monoxide binds with hemoglobin in blood, reducing oxygen transport, causing suffocation and potentially death. Then we come to see suggest two other ways of minimizing pollution of the air by these two gases other than using a catalytic converter. So we are saying we suggest other ways of minimizing pollution by these two gases here. Pollution of air by these two gases apart from um, using catalytic converter. So in answering, we are saying use of cleaner fuel. So instead of using the fuel that uses fossil fuel, use of cleaner fuels such as electric vehicles or regular vehicle maintenance to reduce emission of that. Okay. Then 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 we go to another question. Question 8. The diagram below shows the setup of the apparatus that would be used to prepare gas X. So this is a setup of an apparatus that is used to produce gas X. We have hydrogen peroxide, and then we have magnesium 4 oxide, I think magnesium 4 oxide here. Okay, so hydrogen peroxide is used to prepare hydrogen. So the chemical equation is like this. So hydrogen peroxide is like H2O2. Yeah. So this should give you something like water and oxygen gas. So if we try to balance we put it to here and put it to here, we shall make the hydrogen 4 and here 4. Oxygen will be 2 times 2, 4 also, then 2 plus 2, 4, yeah. So this is the reaction for hydrogen peroxide. So hydrogen peroxide is used to prepare oxygen. Okay, so we had to put hydrogen peroxide and then magnesium for oxide, which is a catalyst. Then the gas that is produced there is um, hydrogen, I mean oxygen gas. So this is the gas jar, delivery tube, and this is water here. So A, they said A Roman numeral 1, identify gas, gas X. So gas X, we have said it is hydrogen gas, this gas, oxygen gas, I mean. Then Roman numeral 2, describe the chemical identity test for gas X. So how do you identify gas X, which is oxygen? So insert a glowing sponge into the gas. It relights a glowing sponge. Okay, yeah. So you can say gas. You can even say gas X relights a glowing sponge. So why? Because it supports combustion. So oxygen is a very it's a very good gas which supports combustion. So because it supports combustion, it relights a glowing splint. So to relight, it is to bring back a flame. Let's say you have a test tube full of oxygen, then you light up a match, then you put out that flame so that it remains glowing, it remains looking reddish. When you get that thing of matches looking reddish, you bring it back into the test tube containing oxygen. A flame comes out and then it starts burning with a flame. That's what it means to be light. Okay, then we go to the next question. B says, what is the purpose of adding magnesium oxide to hydrogen peroxide? So the answer is that it acts as a catalyst to speed up the decomposition of hydrogen peroxide to water and oxygen. In Roman numeral 2, explain why this gas is obtained using the method shown in the diagram. So like why is this gas obtained by this method of collection of water? So the answer is the reaction induces explain why the gas is obtained using the method shown in the diagram. The reaction produces oxygen gas rapidly, magnesium 4-ox speeds up the reaction without being consumed. No. So I think the answer here was wrong. So you can say because there are two answers here. You can say one because oxygen is insoluble is slightly not the one saying insoluble is slightly insoluble in water, not very soluble. It is slightly insoluble and it is um, is lighter than, I think it's lighter, the written is wrong. It is lighter than air, and it is lighter than air. Okay, when we move to another question. So this question C says, the flow chart shows the preparation of nitrogen and argon from air by fractional distillation. Okay, so this is a flow chart, a chart which contains two arrows. They can also call it a flow chart. So we're saying the flow chart shows the separation of nitrogen and argon from air by fractional distillation. Okay, there's filtered air undergoes process X. You have liquid air. Then liquid air undergoes process Y. You will get nitrogen. You get argon. When we're saying Roman numeral 1 describe the processes that takes place at X and Y. So you have air, filtered air. So filtered air becomes liquid. What process is that? So this should be either condensation or liquefaction. So we call it either condensation or liquefaction. Yeah. So then this is nitrogen and what? And argon. They are both in liquid here. Then they end up separating. Nitrogen goes the other way and argon the other way. So what is that process? So that should be fractional distillation or cooling. Or heating them back. So in answering, we do answer this. Yeah, so the X process X process X, we are saying the process is cooling and liquefaction of filtered air. Then process Y, the process is fractional distillation of liquid air. Yeah. Then give one use of nitrogen, and we are saying that nitrogen is used to provide an inert atmosphere in the food packaging industry to prevent oxidation. Yeah. So for example, when you buy jiggies, that pack of jiggies has got air there. That air is nitrogen. So nitrogen, because it's not very reactive, it prevents food from going bad. So by the process of oxidation. So nitrogen is used to provide an inert atmosphere. What do we mean by the word inert? Inert meaning unreactive. So nitrogen is used to provide an unreactive atmosphere in the food packaging industry to prevent oxidation. When we move on to these other questions, like C2 say the calcium hydroxide or slaked lime is an industrial alkali. Calcium hydroxide or slaked lime is an industrial alkali. Roman numeral or A explain Roman numeral 1 the meaning of the term alkali. Then Roman numeral 2 how explain how calcium hydroxide is produced, starting with limestone. Then B give two large-scale uses of calcium hydroxide. Then C a weak solution of calcium hydroxide is called lime water, and it is used to test for carbon dioxide gas. And construct a chemical equation for the reaction. Include state symbols, 2 marks. In most cases, they put 3. I don't know why they did put 2. Then, Roman numeral 2, give the chemical name of the salt produced during the reaction. Then, Roman numeral 3, describe what is observed during the reaction. Okay, so I'll start with this one. Calcium hydroxide or select lime is an industrial alkali. A. Explain Roman numeral 1, the meaning of the term alkali. So in answering, you should know that an alkali is a soluble base that produces hydroxide ions in solution. That's what an alkali is. It's a soluble base that produces hydroxide ions, these ones here, in a solution. Then we go back to the next question. It said Roman numeral 2. Explain how calcium hydroxide is produced, starting with lime. So when you have limestone, which is calcium carbonate, how do you use that to form calcium hydroxide? So this is what we are now answering. We are saying limestone, which is calcium carbonate, is heated to produce calcium oxide, which is quicklime, and carbon dioxide, which is this reaction. Calcium carbonate, which is limestone, heated to produce calcium oxide. This one, calcium oxide, which is quicklime, this one, and carbon dioxide, this one. Calcium oxide, which is this one, is hydrated with water to produce calcium hydroxide. So calcium oxide, which is this one, is hydrated, reacted with water to form calcium hydroxide. So this is how you describe the formation of lime water from limestone. When we get back, I think we're saying yeah, we have done this. And we're saying B, give 2 large-scale uses of calcium hydroxide. So, like, what is calcium hydroxide used for mainly? So you are going to say, so the answer should be here. So it is used in water treatment and manufacture of paper. Yes, so it is used in water treatment and manufacture of paper, even manufacture of cement. So we can also talk of manufacture of cement. Okay. So now we get back the same. See, a weak solution of calcium hydroxide is called lime water, and it is used to test for carbon dioxide gas. Construct a Roman numeral 1. Construct a chemical equation for the reaction. Include state symbol. So this is the reaction of calcium hydroxide and carbon dioxide. They give calcium carbonate and the water. Then we go back. Roman numeral 2, the same. Give the chemical name of the salt produced during the reaction. So the chemical name should be calcium carbonate. Yeah. Then the same. Describe what is observed during the reaction. So you explain what is observed during the reaction of calcium hydroxide and carbon dioxide. So in describing there's what formation of white precipitate here. We're saying describe what is observed during the reaction. We're saying formation of white precipitate. Okay. Then we go to another question. So this question says carbon dioxide can be prepared in the laboratory by adding dilute hydrochloric acid to calcium carbonate as shown in the following diagram. Okay, so this diagram is talking about preparation of carbon dioxide. So we are revising on preparation of what? Carbon dioxide. Okay, so we're saying it can be prepared in the laboratory by adding dilute hydrochloric acid to calcium carbonate. So we have calcium carbonate here, then dilute hydrochloric acid is added, so the gas is produced. A gas passes through concentrated sulfuric acid, then again it comes out here as carbon dioxide gas. Then they're telling us to say, name the two substances that would be produced in the reaction besides carbon dioxide. Okay, so when you are reacting calcium carbonate like Ca, why are we not drawing? We are not in the drawing mode. What have we done to move ourselves from the drawing mode? Okay, we are back the drawing mode. Okay, so now if you are reacting calcium carbonate is CaCO3 plus hydrochloric acid, which is HCl. This is a carbonate, this is an acid. So a carbonate gives you a salt like calcium chloride. So it will be calcium chloride. Then what else is formed? Carbon dioxide, the gas which comes out there. What else is water? Okay, so like here you put a 2, then it is balanced. So that is that. So when they said name the two substances that would be produced in the reaction besides carbon dioxide, it is just calcium chloride and water, right? Then write a balanced chemical equation for the reaction, which is this one. So we'll start in the same scene. Roman numeral 1, name the method of collecting carbon dioxide shown in the diagram. Then 2, give the property of carbon dioxide that makes it possible to be collected by the method named in C1. Then D, what is the purpose of the concentrated sulfuric acid in the experiment? Then E, explain why carbon dioxide cannot be prepared using dilute sulfuric acid with calcium carbonate. Then F, give two industrial uses of carbon dioxide. So in answering, like, name the two substances, so that one we can say calcium chloride and the water. Then the other question was like write a balanced chemical equation for the reaction. So the balanced chemical equation for the reaction is this one: calcium carbonate, hydrochloric acid, calcium chloride, carbon dioxide, and the water. Then when we go to the C1, says name the method of collecting carbon dioxide shown in the diagram. So this method is downward delivery. So the carbon dioxide is going downward like that. Okay. Then we come to the other question. Give the property of carbon dioxide that makes it possible to be collected by the method named in C1. Like, what makes it possible for it to be collected by this? It is denser than air. The same carbon dioxide is denser than air. Then we go back, we are saying D, what is the purpose of the concentrated sulfuric acid in the experiment. Like this concentrated sulfuric acid, what is it doing in here? So in answering, we are saying to absorb moisture and dry the gas. Yes, so this gas has to be dried because it contains water. Okay, then we go back to the question. It says, explain why carbon dioxide cannot be prepared using sulfuric dilute sulfuric acid with calcium carbonate. So in answering, we're saying because dilute sulfuric acid reacts with calcium carbonate, producing frothy and less pure carbon dioxide. Okay, then we get back to the question, which says, give two industrial uses of carbon dioxide. So one, we are saying in fire extinguisher, then two in carbonation of drinks. Okay, then we go to the next question. Lime is an important compound in industry. Lime is an important compound in industry. Roman numeral one, Roman numeral one, state the chemical name of lime. Then Roman numeral two, describe how lime is obtained from limestone in a large scale. Then include an equation in your answer. Then B, Roman numeral one, give two uses of lime. Then Roman numeral two, what environmental problem is likely to arise or be caused by large scale production of lime? I suggest a possible solution to the problem. So we start answering. A, Roman numeral one, state the chemical name of lime. So the chemical name of lime is calcium oxide. Then to describe how lime is obtained from limestone on a large scale, include an equation in your answer. So you can say that limestone, which is calcium carbonate, is heated strongly in a lime kiln. This causes a thermal decomposition to form calcium oxide, lime, and carbon dioxide gas. So you write an equation like that, you are done. Then we get back to the Roman numeral one, give two uses of lime. Then you say, okay, used in the manufacture of cement and also used to neutralize acidic soils in agriculture. Also, it is also used to neutralize acids in the water in rivers. Okay. Then we go to the other question. Roman numeral 2. What environmental problem is likely to arise or be caused by large-scale production of lime? Suggest a problem. Suggest a possible solution to the problem. So in answering, I'm saying environmental problem, large-scale production releases carbon dioxide gas, which contributes to global warming and climate change. Possible solution, use carbon capture and storage technology to trap carbon dioxide before release. Okay, so we use what we call carbon capture and storage technology to trap carbon dioxide before release, or promote the use of alternative energy sources to reduce reliance on fossil fuels for heating lime kiln. Also, plant more trees so that they can absorb the carbon dioxide produced. Then we move on to the next question. So this next question also came on nitrogen. This we already answered. Or we didn't finish, or it came in a different way. Or it came again. So this question came, but a little bit different. So it was repeated with addition. Okay. So C2 the same name. Nitrogen and argon are both elements found in air. A. Draw the electronic structures of nitrogen and argon. B. with reference to um, no, I think on this one, this other part I left it when we answered. It's the same question. Okay, so this we already answered it. Let's go to another question. Okay. So this one we already answered it. Let's look at this question. Question is saying B8, three gases A, B, and C have properties shown in the table. So we have these gases A, B, C. Their property A more denser than air, B less dense than air, then C more dense than air. So there are two, A and C are more dense than air. Then solubility in water, A is soluble, B is also soluble, then C is insoluble. Then appearance, then they are all colorless. They don't appear. You can't see their color. They don't have color. So then some apparatus used to collect gases are shown in the following diagram. Okay, there are this apparatus X, apparatus Y, and then apparatus Z for collecting these fluids. Before we go ahead with answering, let's try to analyze. Let's try to analyze this question. Needed analysis. So like air, the gas is more denser than air. Which method? In terms of water, it is soluble. Which method can you use? You can use this one here, X. So air, you use X. Because since it is more denser than air, downward delivery will work. You bring it like that, then it will sit, then it will remove the air, will run away, will be displaced, then air will come here. Okay, so downward delivery or displacement of air. So, and it is soluble, you cannot use water. Then the gas which is less dense than air, it's this one here. So B is for Y, because it is less dense than air, and this one, the less dense than air and is soluble. So if you use this one, it can dissolve in water. So you use this one without water. So that because it is less dense, it brings what we call upward delivery. So the gas will come upward because it is lighter, and then the air will escape downward. So this one is downward delivery, which leads to upward displacement of air. This one is upward delivery, which leads to downward displacement of air. Then this one more dense than air and is insoluble. More dense than air and is insoluble. It's supposed to come here, yes, because it can come there. But now it will go there like that, yeah. Yes. And then it will start pushing the air down and the water will come down. Yeah. So C is to Z. So let's see. So now we are saying which method A, which apparatus X, Y, or Z is most suitable to collect gas. Roman numeral 1 A. So A collected by apparatus Y. Is it AY collected by Y? Downward delivery denser than air. A more denser than So it is corrected by apparatus X, not Y. There was mistake X. Then A more denser than A. Yeah. See? Down on delivery denser than A. Yes, it is X. X is the one, not Y. Yeah. Then B less denser than A. B should go for Y. B Y upward delivery less denser than A, so Y. So B is upward delivery less denser than A. Okay. Then yeah, we are done. Then B gas C can be collected using Z. Okay. So gas C can be collected using Z. Okay, then they're saying state Y apparatus Z is more suitable than apparatus Y to collect gas C. So apparatus Z is more suitable to collect gas C than Y. What is the reason? So the reason is the apparatus Z is suitable for gas because it is insoluble in water. Yeah. In Roman numeral 2, state Y apparatus Y is more suitable than apparatus Z to correct B. So apparatus Y is more suitable for B than Z. So the answer is that apparatus Y is more suitable than Z for gas B because gas B is soluble in water, so water displacement is not suitable. Yeah. Then C suggest a name of a gas that would be collected using apparatus X. Apparatus X. What gas is suitable for this? Because it should be carbon dioxide, right? Gas collected by apparatus X could be hydrogen. No, this is carbon dioxide because apparatus X requires a gas which is denser. Hydrogen should use this one because hydrogen is less dense than air. Okay, so we are done with this one. Then we come to this one. The flow diagram shows how lime is manufactured. So this, we have been talking about lime. Now they've brought it in a flow diagram. So substance X gets decomposition to substance. So lime starts with always limestone. Then if it decomposes, this is decomposition of heating gives us calcium oxide and carbon dioxide. Then this calcium oxide, hydration of calcium hydroxide, you add water, it gives us substance Y, which is calcium hydroxide. So they're saying A, Roman numeral 1, name process A. So now, here you have calcium hydroxide goes back to limestone. So what is process A? Then Roman numeral 2, write a balanced chemical equation for the process A. Like for going back from calcium hydroxide to that. So let me see other question. Then describe how substance Y, substance Y is this one, calcium hydroxide, which we have identified. So describe how substance Y would be used to test for the presence of a named gas, which is carbon dioxide in this case. Then C, 1. Give a metal that would be purified by substance X after its extraction. Then Roman numeral 2, write a balanced chemical equation that shows reduction during extraction of the metal you have given in C1. So nanometal and metals are being combined in one question. Then step 1 use of a named alloy of the metal you have given in C1. Then Roman numeral 2, other than alloying, how would you prevent the metal you have given in C1 from corrosion? Okay, so let's begin answering. Answers should be, we begin from here, right? So here name a process A, which is this one. So that should be precipitation. So okay, process A, and the mistake is precipitation. Okay, it's precipitation. Why? That's when I realize nicely. You have limestone comes to calcium oxide, you hydrate it from calcium hydroxide. Calcium hydroxide goes back to limestone. What reaction is that? Precipitation where you get calcium hydroxide, these are brackets, you react it with carbon dioxide, you form calcium carbonate plus water. So the process of forming this one is precipitation. So, and they are saying name process A, this is precipitation, and write a balanced chemical equation for the reaction. So for this reaction, this is the balanced chemical equation. Not this one. So it is calcium hydroxide plus carbon dioxide gives us calcium carbonate plus water. So you count calcium 1, hydrogen, because there's a 2 outside here too, and there are 2 there, oxygen, there are 2 here plus these 2 here, 4, so 3 here plus 1, 4, and carbon 1, it's balanced. Then we come to the other question. B, they're saying describe how substance Y would be used to test for the presence of a named gas. So we are saying substance Y is lime water, which is calcium hydroxide. When carbon dioxide is passed through lime water, it turns milky due to the formation of calcium carbonate. Good. Then we go to the other question, which is C1. Give a metal that would be purified by substance X after its extraction. So substance X, remember, is limestone. So limestone is used in the extraction of which metal? Iron. So in answering C1, metal purified by substance X is iron. Then they said write a balanced chemical equation that shows reduction during extraction of the metal you have given in C1. So we are writing a reduction reaction of iron. Iron is reduced. When you have iron, iron comes from hematite, which is iron 3 oxide. So iron 3 oxide in the blast furnace is reduced by carbon monoxide. So iron 3 oxide, which is hematite, plus carbon monoxide, it gives you iron and the oxygen. So it is reduced. So reduce, there's what we call in chemistry redox reaction. Redox, not this one. Redox reaction. So this redox has got two weights. Red is a reduction, then ox it's oxidation. So reduction is the removal of oxygen from a substance or addition of hydrogen to a substance. Just listen. Reduction is the removal of oxygen from a substance or addition of hydrogen to a substance. Then oxidation is the addition of oxygen to a substance or removal of hydrogen from a substance. So oxidation is the addition of oxygen to a substance or removal of hydrogen from a substance. So when they said we write a reduction of that metal ion, it means we write how oxygen is removed. So it has iron, 3 oxide, it has oxygen here, but here it has no oxygen. So iron has been reduced. Then this carbon monoxide becomes carbon dioxide. It has gained more oxygen, so it has been oxidized. Because sometimes they can ask you which one has been oxidized and which one has been reduced. So like in this one, iron has been reduced, iron ore has been reduced, while carbon monoxide has been oxidized. Okay, so let's go to the other question, which was like D1. State one use of a named alloy of the metal you have given D1. So the metal was iron. So the named alloy of iron is steel. Where is steel used? Construction of buildings and bridges. Then we get back. Other than alloying, how would you prevent the metal you have given in C1 from corrosion? So how can we prevent iron from corrosion? So we can say painting or coating the iron or steel surface, galvanizing or coating with zinc, and oiling or greasing to prevent exposure to moisture and air. Yeah, so this one is coming from prevention of corrosion. So corrosion, which is the wearing out of metals, is prevented by painting or coating, galvanizing, which is coating with zinc, or oiling or greasing. Okay, these are some of the methods. So let's go to the next question. So this is our next question. Okay, so question D8 says the following diagram shows the laboratory preparation of a gas and its collection. Okay, so this gas is lighter, so we already know this gas when it goes like with hydrogen. So we have dilute hydrochloric acid, granules of metal. The moment you have acid, for example, hydrochloric acid plus a metal, we don't know, maybe let's say magnesium, it will form like a salt, like magnesium chloride, and the gas will always be, and the gas which is always hydrogen. So when they say M, identify Roman numeral one error in the setup in the diagram shown. So the delivery tube is not submerged in water inside the gas jar. Yeah, so this one was supposed to be submerged in water like, so that the gas which is collected there is pure. Then the same identify Roman numeral 2 gas X. So the gas X is hydrogen gas. Then we go to the next question. Predict what will be observed if metal Y is replaced with copper. So the answer will be no gas will be produced because copper does not react with dilute hydrochloric acid. Yes. So if you get, instead of having this metal Y, you use copper here, you won't see any reaction. Why? Because copper does not react with acids. Why? Because copper is lower in the reactivity series than hydrogen. So it cannot displace hydrogen from the acid. If you get copper, for example, plus hydrochloric acid. Okay, before I demonstrate this, let me demonstrate first the other one. If I get like zinc, for instance, plus hydrochloric acid, I will get zinc because it's more reactive than hydrogen. It will come and displace hydrogen there and sit there. So zinc sits there with chlorine and there's O2 there. Then this hydrogen comes along as a gas. So, but if I were to get copper plus hydrochloric acid, what will be the result here? If they put X, they'll say what was produced was the Z and the Y. They'll say identify Z and Y. You see here, copper is not reactive than hydrogen. It is not higher in the reactivity series. It is lower in the reactivity series than hydrogen. So it will not remove. So if they say what were the product, it will just still be copper plus what? Plus hydrochloric acid. So sometimes this is where even examiners play on your mind. They want just you to apply the concept to say copper cannot displace hydrogen from this, but they can just get this, then they put Z and Y and say identify them, and you'll be saying, that question was hard. No, it was not hard. So yeah, so predict what will be observed if metal Y is replaced with copper. No gas will be produced because copper does not react with dilute hydrochloric acid. Then C says with reference to air pollution, compare the use of ethanol and diesel fuel. So we are going to say ethanol burns more cleanly than diesel, producing less smoke and fewer harmful gases. Okay, let's see. Yeah, so we end with here is where we end with nanometals. I think we have not seen a question on nitric acid, so you do it wisely, guys, to revise on nitric acid. So we have not seen a question on nitric acid. I think I haven't seen a paper where nitric acid was. So let us revise also on there. So for now, we end here. Bye and see you in the next revision.